All right, welcome. Rediscovering the SPL. You see that rediscovering is in parentheses. There's actually two reasons for that. First of all, it's a bit selfish, because it means that on the conference websites, my talk is normally sorted at the top of the list. The second reason is that most of you probably heard of the SPL, worked with the SPL, but pretty much abandoned the SPL. So today it's about rediscovering the SPL again. So I had a small introduction. So my name is Joshua Thijssen. I do stuff mostly with PHP. Not really important, but if you have some questions, comments on me or the talk, then you have some information here to contact me. So first of all, how many of you have actually used the SPL? Okay, a little bit rephrasement. How many of you have ever used the SPL and didn't went nuts? That's a whole lot less. Yeah, and this is the main problem of the SPL, because when you want to do something with the SPL, the first thing you're going to do is check SPL documentation. And where can we find SPL documentation? And don't say Stack Overflow. That was the first time on the last conference, Stack Overflow. Now, obviously, php.net, right? So when you go to php.net/SPL, you get something like this. What's the SPL? It's just a one-liner. It's one command posted a year ago, and that's it. Can't do anything with that. I'm sorry. I really want to use SPL, but with documentation like this, it's completely useless. So one of the main problems is there is not enough documentation. So even if we want to use it, we really can't. We really don't know how. There are very few examples, and even the examples that are there, some of them are even wrong or missing like really good content. So it's not helping. Now, normally when you have an SPL talk, you have like these 5 chapters, and I go over them and explain you a little bit on how it works. I want to do a little bit different today, because today I want to do a little bit of SPL and PHP in general bashing. Now, obviously for me, that's really awesome, because I can do 1 hour of bashing PHP and SPL without any repercussions. But I want to let you know on the things that actually is being done in the SPL that makes your life, well, miserable. You know, the things that you don't take for granted, things that are wrong, things that are incorrect, things that doesn't really fit in the naming that they are. So I want to talk about that, most of the things. I don't want to scare you all away from the SPL, because honestly, the SPL is really, really awesome. And if you know how it works, there's a lot of potential that you can gain from the SPL. So hopefully I have more people using the SPL than scaring away today. So if that's actually my thing for today. So let's start simple with the interfaces. One of the first interfaces that you will learn when you're dealing with SPL is called Traversable. However, that's not an SPL interface, in a way that it's not defined. If you go to SPL and check the interfaces, it's not there, because they decided, okay, this is not really SPL related, so we move it to like the core interfaces. But still, it's a big part of what we do with SPL. Okay, how many of you have ever used the Traversable, who know of the Traversable interface? A few people. Okay, that's good. How many of you have actually implemented the Traversable interface? You succeeded? Okay, because the Traversable cannot be implemented. Oh yeah, there's a lot of trick questions around today. No, it will, well, not 100% correct. You can implement it, but as soon as you're going to use that interface, then PHP will throw an exception that you cannot use it, and you have to use either an iterator or an Iterator Aggregate. So what's the use of Traversable? It's not really usable if it's not being implemented, but Traversable can be detected. So you can use instance of to detect if something is traversable. What happens is that if something is traversable and you put that inside for each, then for each can see, okay, this is a traversable object, and instead of doing normally iterating over the properties of that object, it will behave on whatever that traversable interface defined. Now, traversable is something that is used inside the PHP core. So if you're a core developer and doing C, traversable makes sense. But from us, it doesn't really make any sense because we cannot really change the way how traversable is used. So this is where Iterator comes in. Again, Iterator is still not an SPL interface, but Iterator is a way of us to have a sort of control over traversable, the way how we traverse things in PHP userland. The Iterator interface defines 5 different methods you can use: current, key, next, rewind, and valid. And that pretty much shows you how to behave inside of for each. So you can use these 5 functions to change the behavior of an object when you use for each. Now, most of you, if you ever used iterators, this is all pretty common knowledge, hopefully. When you have iterators, there are a few different types, and I will explain a little bit later on what that is. But first of all, we have the standard iterator, which is something that uses one of those 5, that define those 5 methods. But there's also something called a filter iterator, which still is an iterator, but actually accepts another iterator to filter out data. And I will show you a little bit later on how that works. But a lot of iterators we are using are actually filtering out data taken from other iterators. There's another thing called an Iterator Aggregate. Anyone ever used that one? Nobody? Unbelievable. Sort of, kinda? All right. Iterator Aggregate is pretty much an iterator, so it extends the traversable interface as well. However, an Iterator Aggregate is not an iterator by itself. It has an iterator, but isn't an iterator. So that's something you will see when you actually separate concerns, when you have an object that's a business object that can be iterable, but you don't want that inside that object. When you have something like that, normally you use an Iterator Aggregate. If you are looking at the big frameworks, Symfony 2, Zen Framework 2, you will see that a lot of things in there are either an iterator or mostly an Iterator Aggregate. So there's a really good place to look for on how iterators in general are actually working. Now, let me say how or why you should use iterators, because for each works perfectly. Suppose I have something like this, just a little bit of code. Does anyone know what this is doing? Sort of. It reads the current directory and it prints all the files out there, right? So this is like our business logic. It's very simple, it just prints out, but could be really, really complex, obviously. If you think about WhatsApp, it's $16 billion, like these 2 lines, at least it's a few $1 million, right? So that's our business logic, that's our application, that's the thing we want to put out in the public. Now, you have this deployed, and this is all running smoothly, and now somebody comes over to you and says, this is nice, but we only want to display MP3 files. So you do something like this, probably, and everybody's like, oh no, I never have done that in my life. Yes, you have, trust me. So what you do is, inside the while loop, you actually say, okay, you know what? I check if the file that's there, if that ends on .mp3 with a regular expression, and if it doesn't, I'll just continue with the next file, and if it does, I print that file. Job done. Quickly, issue, deploy, more money. Perfect. But this is not really a good way to do things. Obviously, hopefully you agree with me. Because what would happen if we would filter all MP3 and all JPEG files? We have to change that code again. What if we need to filter all MP3 files that are larger than 6 megabytes? What if some other customer says, no, I don't want to filter something at all? Or what if we have to search subdirectories? Or what if we have multiple directories? Your whole code would be a complete mess. and we like to call that legacy code, but it doesn't end well if you do stuff like this. But the main problems with this is that we cannot test it. That code is untestable. That code is unmaintainable, and that code isn't reusable. So let's change it and let's use iterators. So this is pretty much the same thing what we did before, only with iterators. And even if you have no idea what a directory iterator is, you probably understand what this code says. So I have a directory iterator which iterates over the current directory, and then it shows all the paths of all the files that are there. Now, again, the same question. I want to filter everything that's an MP3 file. So I do something like this. So I have the directory iterator, and I move that, I change that to a regex iterator. Now, again, if you have no idea what a regex iterator is, you still understand what this is doing. So you get the directory iterator, you put that inside the regex iterator, and then I'm going to use that. So it filters out data. So you can chain those iterators together. Do you see what the difference is between doing this and doing the preg match in the first example? Anyone has an idea? Except for using SPL, obviously. It's testable. Yeah, what I'm actually looking for is that we change whatever we want to do with our business logic. We move that outside of our loop. So we have a simple loop that does stuff. So like this is our business logic loop, the for each loop. And everything that needs to be fed into, it's moved outside. Because now we can do stuff like this. So we have a directory iterator that filters out MP3s, that filter out everything between 0 and 6 megabytes. And there's a limit iterator. And the limit iterator, what should it do? What do you think? Guess? Simple. So offset limit. So it returns the 10th MP3, that's 6 megabytes or less, and it returns only 5 of them. But everything is outside the loop. There's no hex inside here. Not bad, right? Hopefully. Does anyone with me not agree that this is a better way than the first setup? Cool. Nobody dares to raise their hand right now. Now, because now everything is reusable, because we can use those iterators anywhere we want, in every different order, in every different form. It's testable because now we can test every single separator by itself. We don't care what comes next or what's before that. We can test it easily. And it's more maintainable because we don't need to adapt and change the business logic. We just need to change whatever is being fed inside that business logic. So this is pretty much the case on iterators. Why should you use iterators? Now, let's continue with something else, with another interface called Countable. And this is finally an SPL interface. This is defined inside a SPL. How many of you have used this? A few in the back, a few hands. Okay, cool. Now, Countable, I show you a little bit of an example on what it does. So first of all, I have a simple iterator. And that iterator, without actually putting the code here, assume that it's an iterator that you put in an array and then it iterates over that array. Now, in this case, what would print count IT does? What would it return? Anything? Anybody? A guess? 1? Okay, 1. Why? Because you only give it one iterator to count. So count sees, oh, that's one object, so I return 1. It's pretty basic PHP knowledge. However, let's do something else. I have a countable iterator, which is pretty much the same thing, but only implements countable. And if you implement countable, you need to add a count method. And what it does, as soon as you hit the PHP count function, and it sees that that object actually implements countable, it will not do its own PHP count, but it will actually returns the result of the count method. So it's like a magic hook into the count function, which is really awesome. Because in this case, I put in an array of 5 elements, I give that to the iterator, and when I print count IT, what will I get? 5, obviously, right? Awesome. This is a simple example, but it could be more complex than this. Now, same thing happens here as well. So I have my same countable interface, and now I'm going to filter stuff. So I have the same array with 1 to 5. I put it in countable interface, but now I'm going to limit it again. So the offset limit part, and I want the first element and then 3 items. So what will count IT2 return? What do you think? 1. Who thought 3? Pretty much everybody, hopefully. Now, the reason for this is that the limit iterator does not implement countable. So it just sees, oh, this is an iterator. It's one iterator. Okay, just return 1. So even if you have implemented countable and you're hacking away and everything works nicely, then all of a sudden you're going to filter iterators, and bam, all of a sudden count doesn't work. And you have no idea why. And if you don't understand this, and if you hit stuff like this, after a while, sooner or later, you will find it out, but it's really annoying. These are the things why people won't use the SPL, because they're really getting fed up by stupid things like this. Because why wouldn't limit iterator implement countable? Why doesn't count work, but it did before? The seekable iterator. Many people think it's an iterator, but actually it's an interface. Why it's called seekable iterator? SPL. I blame the SPL. The seekable iterator, again, is an interface, but it allows you to implement seek. And seek is really nice because when you implement seekable iterator, it can actually speed up other interfaces of other iterators. So for instance, the limit iterator makes use of the seekable iterator. So if you do the offset limit thing again, so you have like a limit iterator and you want to start for the 1000th element and only return the next 10, what normally we'll do is that filter iterator will count from 0 to 1000, throw everything away, and then return the next 10. Well, obviously that's not really efficient. So if you can have something called a seekable iterator, then it will see, hey, the iterator I'm actually using is of instance seekable iterator. I can actually use seek 1000, and just like a database, I don't have to go to 1 to 1000. It will actually skip right to 1000 and return the elements. So even if you don't use the seekable iterator, others, like the limit iterator, can use. So if you don't know that and you think things are really slow, this might actually speed it up. But trust me, just from reading the documentation, you probably won't recognize stuff like this. But it can be really important. There are a lot of more iterators, interfaces. None of them are really that important right now. I will come back to a few a little bit later on anyway. So, the iterators. This is always nice. There are a lot of iterators. And since PHP 5.4, there are some really cool ones called the callback iterator, callback filter iterator, and recursive callback filter iterator that allows you to add a callback. So the need of creating your own custom iterators pretty much disappeared because you can use really cool callbacks for that. If you have no idea what an iterator does, and there's a lot of them, and you probably won't know, even I don't know what all of them are doing, you can look them up at this site, lxr.php.net. Anyone familiar with this site? If you are doing like core development or stuff like that, this is probably a site familiar to, because this shows you the source code of PHP. The source code of PHP is on there. But it's not all C code, because what they did is when they created the SPL, they pretty much modeled on how the iterators would work inside PHP. So if you go to that directory, and in this case, the append iterator.inc, you can actually see what the append iterator does in PHP code. So it's much easier for you to figure out what's it doing, why isn't it working the way I think it should work. Realize that this is not really maintained, so iterators evolve. So this might not be up to date, but still it gives you a really good idea on what current iterators are doing. Not all of them are there, but some of them are, and it's really nice to take a look at that. And it's just PHP code inside the PHP core. Now, I showed you there are a lot of iterators, and some of them really don't make sense if you're just starting with the SPL Iterator. That's really recursive. Oh no, there's a recursive iterator as well. Isn't that Iterator? So, would you have something like recursive iterator? Answer, yes. By this time, I'm already, forget it. I'm going to Python. Recursive callback filter iterator. I'm sorry. I think they had like some kind of game on who can invent the longest class names or something. But yeah, if you start with this doesn't really make sense. It's really hard to explain what this stuff is. However, I will try a little bit. Even if you don't get it, I completely understand because it can be pretty difficult. So let's start with the iterator. I said before that for each works on traversable things. And an iterator is a traversable thing. And the Iterator Aggregate is a traversable thing. But inside the PHP as well, there are a lot of other things that aren't really iterators, but are traversable as well. Datetime has some classes that are traversable. Simple XML has a few. And there are a lot of other objects inside PHP that are traversable, but not really an iterator. What Iterator does is it turns traversable things into an iterator. And that doesn't really make sense for things that are only traversable, but it can make sense for things that are Iterator Aggregate. As said before, Iterator Aggregate is not something that it's iteratable by itself, but it has something that can be iterator. So what Iterator Aggregate does is it has a getIterator function. So it will just fetch an iterator for you. Now, the for each loop will do that for you. The for each loop is smart enough to take care of that. However, if you want to filter stuff, like a limit iterator, the limit iterator has a type hinting of iterator. So you need to add an iterator there, not traversable, not Iterator Aggregate, it needs to be iterator. And if you have no idea if my iterator here is actually an iterator or Iterator Aggregate, you need to add code like this. Because now you have to figure out, is my iterator an Iterator Aggregate? So yeah, then I have to get the iterator. Complete mess. I don't want to explain this to people because it makes no sense. So what they did is something like this. You have the iterator, and then you move that iterator inside Iterator. Welcome to my world. And now, the IT2, we know for a fact that it's something that is an iterator. And now we can use that inside the limit iterator. So sometimes you see out of the blue, something, iterator. You have no idea why. It's to make it an iterator, to make sure that's an iterator. Does it make sense? Kinda if you're inside SPL, but for a beginner who has no idea about SPL iterators, yeah, this stuff is really nasty. The recursive whatever iterator. Example. I have an array iterator. I give it an array, full bar, another array inside das. What would the output be? Obviously, this is a strict question, right? So it's, what do you think it will be, the output? Full bar array bas? Yeah. Until PHP 5.4, you were correct. On 5.4, it will actually throw another notice that you cannot change an array into a string or something. But yeah, this is pretty much what's happening. Why is this happening? Because the iterator does only iterate the elements. So it iterates a string, another string, it sees an array, and it sees a string. It doesn't care that that array could also be iterable or whatever. It doesn't matter. It's not its job. So we need a recursive array iterator. Like this. And now the output would be, yeah, exactly the same. So now I changed from Python to Ruby and tried that. The thing with a recursive array iterator, it does not make anything recursive. It allows you to add the possibility to make things recursive. Should it be called recursive array iterator? Absolutely not. But it happened, and so this is what we have to live with. What do we need to do? We need to filter. Yeah, I know. Through a recursive iterator. What does a recursive iterator does? It does pretty much the same thing as a normal iterator. So whatever it is, it turns into an iterator. Fine, I can live with that. But the recursive part is actually, the recursive iterator has code to actually make it recursivable. So it doesn't only add the possibility, it actually implements that possibility. You could implement it yourself, so you don't need to use the recursive iterator, but please do, because it makes more sense. And now, finally, we get our multidimensional array. Yeah, try to explain that to anyone who never heard of the SPL. The recursive iterators add the possibility to recursively iterate over data. You still need to implement it yourself or use recursive iterator. There are a few others that also do it, but most of them doesn't. So yeah, it should have been called recursivable iterator. At least that makes a little bit more sense, but not really, but still. Now, the recursive callback filter iterator, that's pretty much explainable right now because it has recursive, so we can assume that it's something that allows us to recurse over something. Probably don't do it by itself, obviously. The callback means I can actually add a callback filter of a callback function to it. And the filter iterator means it filters out data. So I need to add another iterator on top of it. So that's pretty much what it does. So even though it's a really long name, it makes sense as soon as you figure out what all the small parts are. There was, I think in December or beginning of January, I think, there was a blog post from Cal Evans who was writing about the caching iterator. And he had absolutely no idea what was happening. He was completely lost and he tweeted, okay, could somebody please help me out because I cannot find what's going on. Now I know Cal, he's a pretty smart guy, so if he's like completely lost, things are really bad. And the caching iterator is one of the fine examples that absolutely makes no sense to be inside the SPL, at least not in this way. Because the caching iterator is actually a 2 for the price of 1 iterator. Because in a sense, it caches values, but it's a look-ahead iterator. It shows you what comes next. It can detect, am I at the end of the iterator before it actually hits the end of the iterator, which could sometimes be functional. I will show you a little bit of a crappy example, but at least you have an idea. But that's the main feature, look-ahead iterator. If it was called look-ahead iterator, perfect, it would make sense, but it isn't. It also caches values, but not really. It's really bad in doing all the caching stuff. But it has some powerful two-string functionality as well. It's really awesome. I never ever seen it anyone use. So if it gets, gets lost in the next minor update of PHP, nobody cares, because nobody is using it anyway. So how does it work, the caching iterator? So I have an array iterator ranging A to Z, so I have A, B, C, D, etc. inside it. And I move that inside a caching iterator. Now, if I just loop it, now that caching iterator has something called a hasNext. And it will show you, do you have a next value, yes or no? And if it doesn't, you can do all kinds of cool stuff with it. So in this case, I will just print out that you just reached the last letter before it actually prints that. Maybe makes no sense, this example, but at least it's something that looks ahead. It knows what comes up next, which can be interesting once in a while. So this is the main feature why you would use a caching iterator. If you're going to use it for caching purposes, you will get something like this. So you do the same loop again, and then you type the fourth letter of the alphabet is IT3. So you can use it as an array, pretty much. So in this, it will return the fourth element, which will be, it's not a strict question, D. So that's cool. However, it's an array, so you could change it as well. You could say the third element is now something else. But don't do that, because it will mess up your data. It doesn't actually use the cache data on consecutive calls. So if you have the iterator, and you loop over that, and you do a second loop, and it's already built up its own cache, it's not going to use it. Why is it called a caching iterator? Again, from now I moved from Ruby to Go or Node.js, whatever. So it doesn't do that. And it clears the cache on a rewind. Or if you do a for each loop, then all the cache is clear again, even if you still wanted to use that. So caching, not so much. So yeah, SPL iterators. However, even though I showed you some really bad examples on things that doesn't make sense, and I completely agree with you, and this is the reason why I do it, it's really awesome. It has quirks, it has stuff that doesn't make sense, but it's solvable. We can solve it, but nobody really does it. Why? Because nobody really uses it. Documentation is not always updated. So if the documentation is not updated, we don't know how to use it, and it gets used incorrectly, etc. The naming is really very confusing. Again, with the recursive iterator, the seekable iterator, which is an interface. But in the end, iterators are really worth it. Even if you don't believe me by now, they really are. So that's the iterator part. Most important part for most people when you deal with the SPL. Data structures. Also another important part, but not really that much used. How many have used an array in PHP? Well, really stupid question, because if nobody raises his hand now, okay. How many of you have used an SPL data structure? A few, okay. These are the different SPL data structures that are available in the SPL. SPL doubly linked list, SPL stack, etc., etc. Now, I can tell you a little bit about every structure, but it doesn't make sense. I think last year or 2 years ago, Patrick Alaat was here talking about SPL data structures, which is a really good talk about what data structures are and when you should use it. If you have any questions on the data structures, just try and view back that talk, because it explains a lot more than I can do. The main problem, I don't know if it's a problem, is that every data structure has its own strengths and weaknesses. And those could be defined in something called a big O. So some structures are like really fast, but need a lot of memory. Some structures are really low on memory, but are a little bit slower than other structures. So it's always a trade-off between different types of metrics, between time and space, etc. Those things can be defined in something called a big O notation. Doesn't really matter what it is. Just look at Patrick Alaat's talk for that. However, what a lot of people don't realize is that even if you think that you should use a PHP of an SPL data structure, the PHP arrays by itself are really good. In fact, the PHP arrays internally in the PHP core are used for pretty much everything. So all the methods, properties, and constants of a class are actually stored in the same structure that the PHP array uses. Everything that is like the server variables, your post variables, etc., is all used with the same data structure. It's called a hash table. They are really cool because there's a really cool balance between time and memory, basically, and they're really fast in doing lookups, and they're really fast in putting data inside. So even if you have no idea what to use, stick to PHP arrays unless you really have a good reason to move to something like an SPL structure. There are reasons for that, only not as much as people might think. Now, if you, anyone have seen the talk about with Patrick Allard about the structures? No, a few. Okay. So what he does is like a sort of quiz. So he visualizes structures, and you have to guess what it is. And I thought it was so funny, so I want to show you as well. So let's start with something like this. What kind of data structure am I looking for? A stack? Yeah, all right, that's a stack. Something like this. It's a sort of a queue. It's a Dutch queue, actually, but yeah. I'm a bit embarrassed about this one. It's a sort of linked list. To be mostly correct, this would be a drunk Dutch linked list. But yeah, this one. Object storage. My favorite when I fly back home, because I can use the white one. Priority queue. This one is a bit of a tricky one. Sorry? Tree? There is not really a tree there. It's SPL heap. Because SPL heap uses a tree. There are other ways to display a heap, but I thought I'd just be nice. Last one. Somebody actually told me SPL very large array, but that doesn't exist. It's actually fixed array. Actually, they can move a little bit, but it's fixed enough. Point being of SPL objects, use wisely. For instance, SPL stack and SPL queue are really fast on doing sequential reads, like iterate over for each loop. However, if you're going to use them for random reads, like item 6 first, then 22, then 63, then 1, doesn't work. So don't use them for random reads. And what a lot of people don't realize is that fixed arrays, for instance, are really bad for certain things. They think like if I use a fixed array, then I get magically a speed boost. Really doesn't really perform that well. It performs a little bit better, but it depends on how many elements you have, and it depends on how you're going to use. So you cannot really say, oh, change it to a fixed array, and then all your problems will magically solve, and unicorns, ponies, whatever. No, benchmark it before you actually use it, because chances are you actually make your code even worse. And you lose a lot of benefits when you actually use SPL fixed array. So use wisely. How many of you are actually using SPL storage? A few. Okay, cool. SPL Object Storage is really nice because you can use them two ways. You can use them as a map, which is pretty much the same thing we do with arrays. But one of the cool things is you can store objects as keys. You can't do that with normal arrays, at least not yet. But you can do that with SPL Object Storage. This could be really interesting. Another way is to use them as sets. So you create an object storage, you attach objects to them, and you can just ask, okay, does this set contain a certain object? Or you can intersect them, or you can div them, or you can merge them and stuff like that. So there's a lot of cool stuff you can do when dealing with SPL Object Storage as like a normal set, which isn't really something that's inside the PHP, but with SPL Object Storage, you can sort of emulate them. What really cool is, and this is a little bit maybe too far, but you can actually define on what gets stored inside an SPL Object Storage. So normally, you cannot store the same object twice, just like, it would overwrite the same key. However, if I have like a my storage, which extends the SPL Object Storage, you can override the getHash method. And the getHash method is the way on how it will actually figure out which kind of key to use. So I create 3 different objects. Object 1 has a type called foo, second one called bar, and the third one called foo again. Now, when I create my storage, and I'm going to attach the first object, it will add it without any problem. The second one, it will add without any problem. But the third one, even though it's a different object, it will notice that the type is the same. It's a type foo. And the get hash will return the same value. And in this case, it will not attach object 3. Which, with this method, you can do all kinds of awesome stuff. I'm not 100% sure, but I think Symfony 2 uses this type of system for some component, or maybe a bundle or something does it. I've seen it a few times in action, and it's really great to do stuff like this. But this is like the hardcore SPL stuff, so you probably won't do that very often. All right, exceptions. Really cool, because nobody has a clue on exceptions. Absolutely no clue. There are a lot of exceptions available, but nobody knows how to use them, and there's always discussions, oh no, you should not use it this way, and this exception is for that way, etc. The exceptions are based on two different base classes, the logic exceptions and the runtime exceptions. To be honest, I'm perfectly glad if you use any logic exception for when you need to use a logic exception, and I'm perfectly glad when you use any runtime exception when you need to throw a runtime exception, because there is too much strangeness going on to figure out which is the best exception. Just try to find the best exception, and if it doesn't, well, try something else. For instance, I have a simple method, and that has an argument string, str, and if that string is the Spanish Inquisition, I throw an unexpected value exception because nobody expects Spanish Inquisition, obviously. However, this is wrong, because unexpected value exception is the wrong type of argument. It's a runtime exception, and in this case, you have to throw a logic exception. And now, obviously, you want me to explain to you what's the difference between a logic exception and a runtime exception. If you go on Stack Overflow or any other website, you have two parts. One says this, and the other says that, and nobody agrees with each other. However, how I try to define it is like logic exceptions are exceptions where you as a programmer are in charge of, which you can actually change. So for instance, you are in control over what str is. You know? Even if it's like something that a user gives, you have the power to actually sanitize the data to check if that string is actually the Spanish Inquisition before you actually call the method foo. So in this case, it's a logic exception. You are in control. You can, as a programmer, change that. You can change it into a non-exception. Same thing as here. So if string is not a string, an invalid argument. If the integer is less than 0 or more than 10, you can throw an out-of-range exception. It's still a logic exception, but at least it's not a runtime exception, because there are some runtime exceptions that do pretty much the same thing. Now, however, runtime exceptions are different. Runtime exceptions are, for instance, thrown when you want the result from a database call. Because when you do a database call, it returns, and you say, okay, save this record, for instance, and then it will say, yeah, I've done it, or no, something went wrong. As a programmer, you don't have any effect on that. That's outside your control. So those are runtime exceptions. It also means that sometimes, and even don't really overdo this, is that sometimes you can retry it. So for instance, when you have a runtime exception on a database save, maybe try it again, because maybe there was a hiccup in the network, or maybe something else went wrong. You could try it again. If there's an invalid argument exception, well, you can try the same string again, but still doesn't work. So you could theoretically use the different kind of exceptions to actually, resolve those exceptions. You shouldn't really do it, because an exception is there because it's an exception, but still, it adds the possibility. One thing, actually, this is debatable, not so much the first one. Never, ever, ever throw exception. Because if you throw exception, you are exactly the same as the guy that goes into your bug track system and says, it doesn't work, enter, send. And you as a developer, it doesn't work. Right, What doesn't work? You have no idea. When you throw exception, you have no idea what's wrong. Okay, you could read the message, but now you as a developer or you as only can print it out to like your website. Like, oh, something went wrong and this is the message I got returned. The database was not reached, or invalid credentials, or your data center is on fire, or whatever. So you have no idea, because as a computer, you cannot really do anything with it. You could write a parser that says, okay, if you string match something with fire, then do something strange with it. But no, exception is really bad. Exception is like the blank bug report, it doesn't work. Now, always catch exception is actually saying, like, even if you play by the rules, maybe somebody else doesn't. So if you have a call to a library from somebody else, they might just throw an exception. So even though you maybe want to catch runtime exceptions or logic exceptions, always try to catch the main exception as well, because they might throw it as well. Some people say, no, you shouldn't do that, and you should let that handled by the main exception handler all the way down at the bottom of your application, but it depends a bit on what you want to do. So basically, never throw exception, always try to catch exception. That's the most important thing. Yeah, again, they are really badly documented, so you have no idea on when should you use which exception, and that's the way how it is right now. So, miscellaneous stuff. There are some other stuff in there that's really cool. For instance, SPL autoloading. We don't really have to deal with that right now anymore because of the PSR0 stuff. So that means that we pretty much have taken care of SPL autoloading. Things like SPL file info, temp file info. Anyone ever used those things? Yeah? They're like really cool classes because they pretty much encapsulate everything for a file. So you have a file as an object, and you can do everything you could normally do in PHP, only object-based. Array object, nice one, I will show you as well. And you have something called SPL observer and SPL subject, which are like interfaces you could use to implement SPL observer strategy. Now, Autoloader, and this is absolutely my favorite one. So there's a function called SPL Autoload register, and you have a function called SPL Autoload call. And SPL Autoload call is the default autoloader when no autoloaders are loaded, the default one. What would happen if you actually register the default autoloader? Anyone wild guess? Obviously, it throws a logic exception. Right. Okay, so fair enough. SPL autoload unregister the SPL autoload call. What will it do? Who's in favor for throwing an invalid a logic exception again? I'm raising my hand, but no. What it actually does, it doesn't throw an exception. It will actually remove all the autoloaders that are there. It will destroy the complete autoload stack, and if you let it, it will actually set your house on fire. Never, ever, ever do it like this. I actually, inside the PHP core, and I can show you later on if you're interested in it, there is actually a piece of code that says, if the argument supplied is SPL autoload call, destroy the autoload stack. It's in there. Probably, most probably, it's leftover code while debugging stuff. Hopefully. But yeah, nobody actually figured it out, so they're not using it. But still, it's in there. So strange stuff happens when you supply certain arguments. It's like, how do you call it? The Easter eggs and stuff like that. So if you want to have a really good time, just put this somewhere inside your code and let your colleagues worry about whatever happening to your code later on. Okay, very quickly, array objects. Anyone used array objects? They are really cool because array objects are objects that act like array. However, array objects are really not objects that act like array. And I will show you why. I have an array with a foo and a bar element. I say B becomes A. I add an extra element to B. What will be the output? What will A be? Bar and bash. And B will become full bar bash. Why is that? Because it's something called copy on write. So it doesn't change until, or it doesn't copy anything until something changes, and then it makes 2 copies of A and B in this case. Perfect. This is pretty common knowledge. However, now I'm going to use array objects, and I'm going to add full and bar again, pretty much the same thing. I'm going to say B becomes A again. I add something to B, and I will just, because it's an array object, you can actually use iterator to array to return it as an array. What will be the output? Same thing? Reckon? Obviously not. Yeah, they're both equal. So now I changed B, but now A has changed as well. Why? Because this is a reference. B and A are the same object. They're pointing to the same object. If you don't know that array object is an array, but is an array object and not an array, things like this will be pretty messy. So how can we make the SPL easier? Because that's the main question I'm asking. First of all, buy my book. I can literally say I wrote the book about SPL because there's no other book about SPL. Hopefully it fixes the documentation problem about the SPL, and if it doesn't, you know, it makes good thing for your cat or put on a table or whatever. But you can do something as well. Adoption of the SPL can only happen when developers are familiar with it. There's currently no real way to familiarize with the SPL, so you have a problem. What can we do? Blog about it. If you do something with the SPL, blog about it, what you did, what went wrong, what you fixed, what's not in the manual. If it's not in the manual, try to update the PHP.NET manual as well. It's much easier nowadays to actually add comments on that. The more comments, the more people will know about the SPL, the easier it is to work with that. If you find stuff like SPL autoload unregister, find the quirks, and maybe even solve them if you know how to. This is the only way that I don't have to do this talk in 3-4 years' time. I really want to do it, but I really like to do a talk about the SPL is awesome and there's nothing wrong with it. But the only way to do that is for you guys to actually use the SPL, to document the SPL, so more people can use it and more people can actually figure out what's going on. Okay, any questions? How much time I have for questions? An hour? Okay. Any questions? Nobody? If I was that clear on the SPL, I'm going to ask questions to you guys. You know that, right? We do a written exam. Oh, there's a few.
Hi there.
Hiya.
I saw in your iterator list there's an infinite iterator.
Yeah.
What does that one do?
What do you reckon it does?
I think it does everything forever.
Yeah. It's like the Narnia cat of iterators. Now, actually what it does, normally when an iterator is at its end, it will stop, right? What an infinite iterator does, it will actually see, oh, if I'm at the last element, I will call rewind again, so it will loop. So you have a complete loop. Could be useful. Don't use it without a limit iterator afterwards. Otherwise, it takes a long time before it finishes. There are some valid use cases for that, but it's not something you will use very often. But still, it can be useful in combination with the limit iterator. Okay? Any other questions? To be honest, I totally suck when it comes to questions like this. If you ask me something about all the nasty edge cases, I happily will tell you that. This one, I just know, but yeah.
Okay, so in the last weeks, I came across array objects on the internet,
cool.
And I toyed with the idea of universally using it in our code base.
Yeah.
I live in an environment where things come from an API, and where everything is an array, and currently we use them as arrays, but it would be nice to make them objects, to live in an object-oriented world. And now seeing what you have written on your slides, I'm wondering, do you advise against array objects?
No, definitely not. However, you have to be careful with array objects because I showed you before, they act a little bit differently than normal arrays. So you can't just say, oh, everywhere where I define an array, I can replace it with an array object. It doesn't work like that because there are some precautions on that. However, if you have code that is actually testable, where you have unit tests, and obviously you have them. Soon, okay. As soon as you hit the unit test, you can actually try and experiment with them and see where things will fail. Might not, depends on how you're going to use the arrays. But yes, there are some really cool methods inside the array object that will allow you to do like nifty stuff. So I can't say for now if it's worth the whole transition period, but it might be, it might not be, but you have to find out yourself. And if you have your unit tests in place, then you actually can figure out if it's actually worth it or not.
Thank you.
Right?
Okay, just to interrupt, we're going to take one or two more questions, but to the people at the back, if you want to come in quietly and take some seats in the back, that's okay. If you want to take some seats. So we've got one question at the back here.
Yeah, perfect.
Hello.
Hiya.
Is anyone attempted to make a standard PHP library that normalizes the interfaces?
You know what? Try to post that on the internals mailing list, and I will get the popcorn out, and I will have a lot of fun. No, they don't. But it would make sense to have people around that actually fixes the things that we do. And the only way to fix it really correctly is to actually change the things. But obviously that means backwards compatibility breaks, so you can't do that on every release. So you have to do it like small steps at a time. So it will take a long time to actually fix all the issues we have, but it means that every release it gets better and better and better. But nobody has written an SPL on top of the SPL, no. Would be fun, but no, unfortunately. Okay, one more question.
One more question?
Right.
When writing your own exceptions, I usually extend the exception class. Is that a good idea, or are there logic exception and runtime exception classes to extend?
Personally, I would try to use the logic exception and runtime exception for that, based on what type of exception it is. You have something called a domain exception. So if it's like an exception inside your domain, I try to base that on the domain exception. But yeah, try to use the most detailed exception and use that as a base class. That means it's more easy and more maintainable to catch those exceptions for others to do that. Okay? All right, if that's it, my presentation, the slides and everything is on Joined In. So you can get the slides there and leave your feedback as well. If you have any questions about the SPL later on, you can ask me here or even contact me at Twitter or email or whatever. Okay, thank you.